Working in Azure for like three years now. I primarily focus on customer engagements, helping them build cloud solutions at cloud scale. That's pretty much it. Saket, you want to introduce?
Yeah, so I'm Saket. I've been with Microsoft for 10 years. I just completed 10 years last year, November, and been working on cloud for around 5 years. And primarily in cloud, I do IoT and advanced analytics like machine learning and BI and Power BI. If you guys have been using it.
Okay. So before we get started, I just want to understand from the audience. So the topic is like building high-scale applications. So from your opinion, from your thought process, what do you understand by high-scale applications? Yeah.
High-scale is application which can scale itself with the increasing load.
Okay.
More transactions than expected.
Sorry?
More transactions than expected.
More transactions than expected. Something that you said that can expand.
Expand its capacity to handle the load.
Okay. Okay.
New transaction, multi-geolocation.
So transaction is already done. So transaction is already covered. So anything else? This more users, concurrency, right? Low latency. Yeah.
How many of us think that elasticity is an important component?
Spikes.
Elasticity? Okay.
Spikes. Yes. So dynamic scaling, right? Horizontal scaling, scale up, scale out. What else?
And scale down as well. Yep.
Scale
Great
down.
point. Great point.
Exactly. What about price? Have you ever thought about price? What price do you pay for high scale? Sorry?
It should support the cost-centric architecture.
Cost-driven architecture. Good point. Yes. Anything else? So how do we? So scale comes with its price. How do you balance it out?
Cost per transaction.
Cost per transaction? Sorry? More on-premise? Okay, we'll show some stuff that you can't do on-premises. Okay. So based on the patterns. What patterns?
Architectural patterns like cache aside.
So that's not dealing with scale. You can implement it in other cases. Sorry? So can you give me some examples of high-scale applications that you've come across? Internet banking. So why do you think it's high scale, by the way? Why do you think it's high scale? Good response. Great response. So what we want to do is, so we picked up some scenarios that we have come across over a period of time, and just categorize this high scale into some categories. For example, we want to talk about what do we mean by high scale in enterprise scenario, right? What do we mean by high scale applications, from a big compute perspective, right? And what do we mean by high scale in terms of concurrency, high throughput, low latency sort of thing, okay? So just go through that. Just talk about, for example, what is a high scale scenario in enterprise, right? So we just look at some of the things. When you say high scale, again, so most of the things came out, from an attribute point of view, what does high scale application look like? But how do you address those requirements, right? Any thoughts on that? How do we address? Let's say somebody talked about low latency. Now, how do you address that?
Optimizing.
Sorry?
Queries.
Optimizing SQL queries. Network low latency. Okay.
Geolocated.
Geolocated. Okay. Sorry? Same VNet. Okay. So from our perspective, so we categorize into different areas. So when you look at high scale, how do we address? We can address it from a compute perspective, right? So from compute, we look at like 32 core CPU and 448 GB RAM. I mean, this is the largest compute that's available in the cloud today. Okay, and it's dedicated cores, no hyper-threading on Azure. So the 32 cores is what you get. Again, the two flavors of that: there's 32 cores with hyper-threading and 32 cores with no hyper-threading, dedicated vCPUs. So that's one thing. So we want to look at, for example, the use case for that in enterprise scenarios typically around SQL Server, CRM, SAP, Oracle, those kind of things. Where basically they want to get scale from hardware itself. They don't want to do anything. They don't want to optimize their application. They don't want to change the application. Just lift and shift. They want to get that kind of scale, right? So that's one area. And the second one is storage. So when you talk about a database application, right, the bottleneck lies in the storage, right? So we have storage that can give you like more than 50,000 IOPS. We'll see that in action, right? So that's from a storage aspect. How do you address scale, right? The third one is in the networking aspect. We talked about low latency, we talked about express out and things like that. But the fundamental network innovations that Microsoft has done in Azure, for example, to talk about InfiniBand networks, we can talk about RDMA, right? How you can get 40 to 40 gigabits.
Any guesses on? Let me ask it here. Any guesses on RDMA? Anybody ever come across this term? Oh, you sure? Definitely. But we want to answer from this side. Okay. So how does it help? So typically, let me just probably draw it out here for you. So let's say you have.
Change it to 5.
Okay.
And then the red button.
Okay, great. So you have machine A here and then machine B here, and then you have memory, or you can say RAM here and RAM here. Now, typically, if these two machines have to interact with each other, how would they go about it? They would go through the layer of OS, right? There will be an encapsulation at the OS level, and then maybe at the network level, and then all this encapsulated data will be transferred across, and this will cause a lot of latency as well as a lot of bandwidth usage, right? Now, what RDMA enables you to do is basically allow memory to interact with memory directly through the network. So instead of going through this entire OS layer encapsulation, you allow memory to directly go through to the other side, right? And that makes it much faster. That combined with what Anil was talking about, InfiniBand, which is standard 40 Gbps kind of network speed, you can imagine what kind of IOPS it can give you, right? But one condition, it's not something that you can do everywhere on all the applications. It requires a special architecture, right? Recently, Ethernet-based support has also come in for RDMA, but yeah, you need to architect specifically for this architecture.
So great. So that's from a hardware, hardware perspective, right? So what about platform? Right? When you're building high-scale applications, you need support from the platform as well. So from Azure perspective, we have HPC is primarily we use for high-scale computing, and we also have something like cloud scale, right? So HPC is all about scaling up using humongous amounts of cores and memory, whereas cloud scale is mainly about using commodity hardware and doing taking a scale out option, right? So we'll look at that. So you want to start with. So let's do this. So means we haven't planned for a kind of a rhythm or something, a flow, something. Just go as it comes. So what we'll do is we'll take a look at. We want to do the IoT.
Yeah, sure.
So I want to show the VMs.
Okay.
Okay. Let's duplicate this.
All right.
So what we want to show firstly is from our storage perspective. Just give me a minute here. We want to just quickly touch upon storage spaces and things like that.
Sure. So we have come up with a lot of changes in the last 6 months to 1 year, and I'm not sure how many of you have been reading the announcements on Microsoft Azure storage related changes, as well as how many of you have heard about G series? Okay, quite a few people. What is special about G series? In the world, in India, where? Yeah. So yeah, in the cloud industry, they're one of the largest VMs available, right? Anybody can anybody guess the amount of CPU, the highest amount of CPU available, number of cores basically, or the amount of RAM? And RAM. Oh God! I'm just thinking one person will answer that. I'll give away the bag, but you guys are all aware. Great, amazing.
You just showed me.
That also requires awareness, right? You're looking at the slides. Okay, so when you come to HPC, basically HPC it's not something which is new, right? It's been there for quite a while. So Microsoft has been evolving HPC. So currently HPC is available in the form of something called as Azure Batch, which is a PaaS service. And we also have HPC compute available for hybrid scenarios, as well as how to use HPC in totally an IaaS environment. Okay.
Yeah, so if you see this, this is from a storage perspective. How many of you know about storage spaces in Windows Server? What does it do?
Like you have 2 tiers of hard disk. One is this SSDs and the SAS.
Okay.
And then so the storage spaces move the blocks intelligently between whatever the read writes come on out.
Mm-hmm.
So you need massive reading, so you the blocks move to the SSD and
Okay.
serve to the users.
Okay. Anybody know about JBods? What's a JBod?
Just another bunch of
Disks.
Okay. So what is the use case of a JBod? When do you use JBods?
When you need low performing more hard, you need to increase your storage capacity on-prem with low cost hard disks.
So for example, let's say you have a 100 GB disk and you have a 50 GB disk. Now you want to dump a file which is like 120 GB. Now without JBod, I can't do it. Either I need to have like something like a 150 GB single disk or a 200 GB disk, a single spindle where I can dump my file. With JBods I can kind of add it up and get 150 GB volume. I can dump my file on that. So think of storage spaces as JBods in software.
Okay. So, but then that would not have any redundancy.
We can enable that. So I'm not sure what is the storage redundancy provided by Azure? Storage redundancy provided by Azure. Exactly. So you don't need to, for example, build redundancy in Azure. It's already taken care for you. Right? So every disk you see has got 3 copies of it already done for you in Azure. So what we've done here is this is kind of a software version of JBods, right? So we have created like 32 disks. So this is a D series standard VM. Okay, so it supports up to 32 disks. So you can kind of create a 32 terabyte of a single volume. Okay, now this is, so we've attached a bunch of disks here. If you see this, they're all like 1 TB disks. Okay, now we have something called premium storage. Anybody came across premium storage in Azure for the last couple of days in keynotes or somewhere? What are the key attributes of premium storage? Yes, how much is the IOPS there? Exactly, and that's the intent of this. We want to show you that. Okay, so we heard about it. Now you want to really see it in action. So the way it works in Azure is you want high IOPS. Let's say you want 50,000 IOPS. How do you do that? We use storage spaces. So basically, each disk is stored in a separate storage environment, which gives you the kind of IOPS. Like each disk will give you 5,000 IOPS, right? So when you put it under storage spaces and create a single volume, the IOPS gets added up. So you technically get like 50,000 plus IOPS, okay, with very low latency. So I'll just quickly show you that. So we just created a volume with like about 30 disks. Okay, so with 32 disks you would get like 50,000 IOPS. With about 30 disks, like 2 disks are missing in this. So kind of get about 40,000.
Who can guess why?
Who can guess why? We get lower.
If you
lower
increase
IOPS.
the number of disks, why would IOPS improve? Awesome. Yeah, that's. I think I need one bag. I'm going to give it to you.
Yeah, sure,
right?
sure.
Your name, sir, please. Sorry. Sang Babu. Okay, great. Congratulations. One bag is waiting for you.
Okay, so if you see the sorry. The E drive shows like 29.9 TB. Okay, so now I have a tool called SQLIO. Anybody heard of SQLIO? How do you measure IOPS? So what kind of tools do you use to profile storage? Anybody does that today? This audience? Sorry? Yeah.
To read write on the disk as well as if you are trying to allocate that disk for logs, then it will try to analyze whether it's a write intensive disk.
Correct.
Or if it is for data, then it is read and write intensive.
Right. See, when you're building a high-scale application, let's say you have a very mission-critical high-scale application in enterprise. Let's think of Oracle, right? They want 50,000 IOPS. Now, how do you make sure, at least from a storage system, you're guaranteed that? How do you, from a tooling point of view, you know that this storage subsystem can provide 50,000 IOPS? So, there are a couple of options, right? You have IO meter, like you said. IO meter, you can use IO meter. we also use something like SQLio. It's a very simple tool, Microsoft tool. It's command line driven. We just run and just press the. So just run. So if you just look at the command line here, so this is a command line. We're saying
Everybody
do a
see
read.
that?
Can you see this? Can you see the command
Or
line?
you want us to zoom?
Okay. Can you see this? Okay. So what you're saying is we're just running a command called SQLio. We're saying do a read. The second parameter is read. The third parameter is the number of duration for which I want to run the test. I'm just providing 20 seconds for the purpose of this demo. And I can either provide like two types of tests I can do, either a random IO or a sequential IO. Here I'm saying random IO. Anybody knows the difference between random and sequential? When do you do random? When do you do sequential?
Random for data, sequential for log.
Sequential for log.
So when random for asynchronous,
Asynchronous. Okay. So
Random is generally in the
any answers from this side of the folks here?
Usually in the spinning disk, I think you do a random just to see if that is accurate. Because it is not read from a continuous memory.
So given a scenario, how would you profile your storage subsystem? Whether for sequential reads or random reads?
Random reads.
No, I didn't even give the scenario. How would you know it's random? You pick a scenario, let's say a database. Now would you profile it for random or sequential?
database has to be sequential.
Sequential.
It's how your data
data.
logs.
So there are two parts of the database, right? So your logs and your data,
Right,
transaction data.
right.
So transaction data we would go for random, and the logs we would go for sequential.
So
What if there is a scan happening on the data? I'm not trying to confuse you.
okay, I'll just come to that in a bit. So next parameter is the queue depth, right? So for example, if you just thrust IO requests on a storage subsystem, it's got a defined capacity, right? You cannot address all requests. So it's going to queue a bunch of requests. So what we're saying is, what is the acceptable limit for queuing? So we're just saying you can have an acceptable limit of 16. This is for a SQL Server recommendation. So every database would have a different queue depth. So we're saying for SQL Server, based on the number of processes it's got, the acceptable is around 16 because this machine has got 16 cores, right? So per core we're saying one queue length, right? And the next parameter is the block size or the page size. So typically SQL Server uses 8 KB pages to read and write data, right? So we want to profile with the same similar, characteristics. So we want to just pass in 8 kilobytes. Just we're saying, hey, read 8 kilobytes from the disk and tell me how fast it is, how much IOPS I'm getting, right? And the last parameter is basically a file wherein I'm saying, okay, the data file that you want to test against is residing in E drive. That's pretty much it. And if I just run this command, I'm just going to run it for about 10 seconds. Okay, it's running. So it's going to run. It's going to read 8 kilobytes of data from the data file it's created. I mean, I've already created the data file for the test. So if you just see what it's doing, it's running the test for 10 seconds. It's reading from a file called testfile.dat, and it's reading 8 KB, and it's doing a random read. That's what it means. So this is profiling for SQL servers because SQL Server uses random. It will require random access because a query can look up table A and another query can look up a table B, and the same SQL Server that's addressing both IO requests. So it has to be random, right? So just give it few more seconds. That should be done. So we can also do a similar test for write. So we are doing a read here, right? We can also just change the second parameter -k and pass in W, which we want to do write. Okay. So we are testing against a file of size of 2 terabytes. So basically what we're trying to do here is we're trying to hit every block in a 2 terabyte file to basically saturate the storage subsystem so that we get maximum IOPS. So if you probably run this test with a 100 MB file or a 10 MB file, you probably wouldn't get so much of IOPS throughput. So you really want to have a large file to actually get that kind of a throughput.
Maybe we'll come back to...
We'll just come back to this. It's
Yep.
taking some initialization done. Okay.
So will this write?
Okay, it just completed. So if you just see the...
Zoom.
Just a second. Okay. Now if you just see the response, IOs per second, 32,231 for random access, right? And this is missing a bunch of disks, so you will see in lesser than 50,000, but you can, if you actually added those two disks, you will see in touching 50,000 IOPS, right? Look at the throughput, 251 Mbps, right? And our benchmark shows it's about 200 Mbps. If you look at the article on PM storage, and latencies are average around 7 milliseconds. Okay. Any questions so far on this?
Yep, sure.
Whatever is the product or the API is completely SSD based, what kind of reach? SSD based underlying database we use now.
Right. So what we're saying is we're not calling it as SSD. We're just doing away with that, right? We're just giving you IOPS, this premium storage. We just
more IOPS.
so we can use a combination actually. We just show that in the next one. If you want to do the G series, it's already up and running. So in the G series VM, we actually call it the Godzilla VM. It's got 32 cores, 448 GB memory, 6.5 TB of local SSD. Okay, we'll just talk about a scenario where that can be used. So got to remember that.
How many of how many of you have worked on SQL Server? How many of you working on SQL Server? So you must be knowing about buffer pool, right? So have you come across this term called buffer pool extension recently? Anybody heard of buffer pool extension? No one? Oh, that's strange. Which version of SQL are you using? I'm sorry? 2008 or 12? Okay. So 2014 onwards, we have in-memory capabilities, right? We do also have buffer pool extensions, which basically means that the G series or Godzilla series VMs that we're talking about, which have got the associated D drive, as we call it, in case of Azure VMs, which is nothing but non-persistent kind of a drive, where you cannot keep your data, but it is used for all kinds of temporary activities, right? Now that can be used as an extension to the buffer pool, okay? And apart from that, what other thing can we put in there? Any guesses? Virtual memory is at the process level, right? But anything else in SQL Server? Anything rings the bell? 10 dB, great. Yeah, definitely. I want. I'm gonna watch for
just
this.
look at this. Just temporary storage. You know what this means? Any thoughts on that? It's just local C disk, local disk C drive, and temporary storage.
It gets cleaned out when the VM restarts.
Exactly.
No, when you deallocate the VM. Deallocate the VM. If you delete the VM, you're going to lose that because this temporary storage is coming from physical host on which this VM is running. Right? So when you deallocate the VM and try to bring up the new VM from the VHD, it could probably get hosted on another physical host, which would provide a new local this temporary drive. So if you deallocate the VM, you will lose anything that you store here, right? So we wouldn't recommend to put. This is a no-brainer. You don't want to put your MDF file here, right? So what are the other scenarios where you could leverage this local SSD, right? So that's what he's talking about.
Right. So extension would basically mean it's a very simple SP configure setting, or you can say alter server setting, and you can enable any size of buffer pool extension on that drive, right? So obviously limited by the maximum size available for that drive. So what that will help you is basically it will act as some kind of an L2, L3 cache. Okay. It's very close to the access time of RAM, but it's not exactly the access time of RAM, but it's much better than the access time of disk, right? So that's another feature.
Okay. If you just notice the number of CPUs, there are 32 cores here, and look at the speed. 2 gigahertz. Now, quick trivia question: what is the fastest processor available today? Processor speed. Any platform.
This session is all about biggest, fastest, best. So, pardon us.
We have actually we have 3 more gigabytes actually. 3.5. 4.
That's out of a sci-fi movie. Or we're talking about robotics.
Yeah. It's around 3.1. 3.1. So this is running 2 gigahertz, right? The other machine, the D series standard, that's the highest clock speed in Azure. That's running at 2.6 gigahertz, right? We'll also show another. After this, we'll also show another VM that's even faster. Okay. So that's that. So you want to show the buffer pool?
Sure. So here is, not sure, the screen is frozen. Okay. Well, the server is not in a good shape right now, that much I can tell you, but I can show you the commands which we ran once it appears. So we will not wait for that. So basically, it's a very, as I said earlier, it's a very simple SP configure setting. You may want to reduce max server memory to a minimum so that it accesses buffer pool extensions. And you can put it on the D drive. It will create a .bpe file, okay, of any size that you want, and it will be leveraged as a resource when it comes to disk access or data access.
About the 10 dB, I just want to mention that you should not put the 10 dB on the D drive. This just I heard from the data track. Okay, the reason is because if you have a SQL Server service running on your VM and it comes up, the SQL Server first it first looks at the master DB and then looks at the 10 dB. And if your D drive is not up by then your SQL Server won't start.
Yeah, that's a latency problem, so it may come as a best practice, but one of the main features added to 2014, which is BPE, also allows you to use that. But if you are observing that behavior, then obviously you don't want to do that. But it's not like you should not do that. It's just that if you're observing the behavior very often, then yes.
So we have some connectivity issues here.
So the 3.1 gigahertz that you spoke about, is it applicable for SQL Fast or infrastructure as a service, or is it applicable for both of the environments?
So when you choose a VM of a certain series, whether it is D or A or G, you get to see that, because if you look at A series, for example, the difference between A7 and A8, so they'll both have the same number of cores and same amount of RAM, but the difference will be probably the amount of the speed of the CPU, right? So that way it's differentiated. So you'll get to see the speed that you're selecting, and based on that, the charges will be more. I mean, as compared to the other one.
Sort of two related questions. So, say I'm an enterprise, I'm a company which has software and I hear about Azure and I decide to migrate, right? So, I can, since it's bigger, better and faster, I can, spin up, I can take storage, I can buy more things. But if my app is not designed properly, I'll end up, my app will not perform even on Azure, right? So, does Microsoft have a way in which they can profile, say, the application and tell that, hey, it's good that you're moving to Azure, but even on Azure, you will probably encounter these problems because, you have...
Definitely, that is a disclaimer for every service that we have. So you cannot expect high computing power to solve your, say, for example, indexing problems or statistics problem in SQL Server, right? It cannot do anything about it.
So, a follow-up to his question, do you have best practice or guidelines on how to create and deploy applications for larger workloads rather than just scaling up?
Yes,
Definitely.
of course. That's what this session is all about. So we talked about enterprise. This is an enterprise high scale scenario where you don't need to make, rather you don't want to make changes to any application, like, right? You just want to do a lift and shift, but you still want to meet the demands of the workload. This is a scenario for enterprise. We just talk about the next, a couple of other things. We just talk about how you can leverage scale out pattern, right? So yeah.
One small related question is, say for RDMA you said that it will need to be architected different, right? So what happens to legacy applications which are there, and
Yeah. So you can't use legacy applications. See, today you have very few applications that leverage the RDMA and InfiniBand technology, right? So one is of course the HPC that you just see next few minutes. The other technology that uses RDMA is SNB. Okay, and if you want to build new applications that you want to leverage the InfiniBand and RDMA technologies, there is a .NET library available for you in C#, right? So you just have to implement the way you connect to another node or a network that's built on InfiniBand is going to be different. So there's a library already provided, a .NET library. Just leverage that and you'll have to use that in an application. It's a different. It's not like a simple create object and you just pass a server name. It's a different protocol actually. Right? So there's a library. So if you're building new applications and you want to leverage this, definitely there's a way. There we do have a library available. And we'll see a couple of games that leverage the technology. We'll just see.
Let's go on with that.
Yeah, just do that.
Because here, SQL seems to be down. And
so what you want to do, HPC or?
Yeah, let's show the game first,
Yeah.
and then we'll start with HPC.
Let's take 2 minutes. Okay, I just want you to see this video. Okay, this is about Halo. Any game fans here? Anybody play Halo? You have seen Halo? So this video talks about how Halo is built. Okay, just 2 minutes. So can we? Sorry. Can we have audio, please? One.
Play that.
Some sound. There is no sound.
Well, that's quite a lot of silence. So, yep, I think we are. Okay, you can, Anil, you can play from the.
Pause it.
You can put your mic.
Take this out.
Halo is a rich, immersive story with millions of loyal and dedicated fans. We deliver an exciting and engaging experience to these fans. They need to know what the hot playlist business is today. They need to know what the challenges are. They need to know where their friends have been, what their friends have been playing. Have their friends gotten more medals than them? They need to know all of this, and they need to react to it and interact with their friends in real time. We need to deliver hundreds of thousands of updates per second to millions of players across the Halo universe. We need to get them the right information to the right device at the right time. There was nothing off the shelf that solved the problems we needed to solve at the scale we needed to solve them. So we turned to Microsoft's Extreme Computing Group.
Hundreds of thousands of requests per second across thousands of servers in real time. These guys are crazy. But in extreme computing, those are the kind of challenges we like to tackle.
For us, using Windows Azure was a no-brainer. Platform as a service allows us to get thousands of nodes, abstracting away the operating system without having to worry about a thing. We're able to use storage to store massive amounts of data, and we can use Service Bus to run hundreds of thousands of messages around the system without a problem. Now, we need a programming model that allows us to scale limitlessly, transcending the machine boundaries while still maintaining that real-time performance need that we have.
We took the actor model approach and we built a modern cloud-scale distributed framework optimized for Windows Azure. We call it Orleans, and that's the framework that allows us to build large graphs of live actors distributed across thousands of machines. Those actors can interact in real time. In our lab, we tested one of the real services, handling over 1 million requests per second on just 125 servers.
By leveraging Azure and Orleans, we were able to deliver dozens of services all operating at massive scale.
Hundreds of thousands of requests per second over thousands of servers in real time. Well, maybe these guys aren't crazy, just extreme.
So what we'll now see is, anybody has access to laptops here with internet? You have access?
I don't have internet actually. I have a laptop.
Okay, fine. So what we'll do is, so we'll now look at the programming platform, right? So we saw the hardware, what the infrastructure can provide from a computing and scale perspective. So how do you leverage, a programming platform to basically do a scale-out pattern, right? To answer your question, how do you build applications that doesn't require this kind of big compute, but rather use commodity hardware and kind of have a scale-out. So this is just a game here. It's a tic-tac-toe game. Now we can play this on a 40-core cloud scale environment. Okay. So what we'll do is, I just started a game here. Think of it like, the scenario here is I'm expecting millions of users. I mean, not to play my game actually. Think of a hypothetical situation where a game like Halo, where millions of concurrent users are going to play the game simultaneously, and you want to send messages to every player who's engaged in the game, right? So if you see, I'm just going to launch another browser and start the same game. So it kind of simulates multiplayer situation. Just say grade 1. Okay. So nobody started any game, so I'll just go and start a game. Okay. So player 1 has started a game. I just come back to my browser instance. It says that player 1 has started a game. I just go say join. Okay. Now I've joined the player 1's game. I can go take part in it. Okay. So I'm not sure if you can see the tic-tac-toe there, right? So it says, I just switch to the other player and enter the game. It says your move. So it's player 1's move. So I just go make a move. So you just imagine 2 players are playing this game. You can imagine several thousand users playing against each other, right? In the same environment. Highly concurrent, right? You can imagine. So I just made a move. Just go to the other instance. You can see the move there. So it's my turn. I just go make another move. Just quickly switch over. So if you see, it just, right, is showing up. Now, how do you think this is happening here, right? So just show it again. Just made a move. Switch back. Yes, you see the reflection, right? So we'll again look at one more scenario. Okay. This is kind of leveraging the same platform. So I'll just come to the platform in a bit. Just take a look at the scenarios here. So have you heard of ThyssenKrupp lifts?
Yes.
Right? So this is a kind of a UAT environment, if you will. It's not a production environment, but production environment is very similar to this. So we're just showing some random data here. But if you imagine the production version of this actually shows realistic data. So the idea here is ThyssenKrupp is monitoring all the lift instances across the world. They want to get some real-time analytics from all the lifts that are deployed, and they want to do some predictive maintenance on that. They want to capture some key parameter that can indicate some issues with the lift, and they want to jump in before the a tragedy happens, right? So that's the situation. So now, from a monitoring control room point of view, there's just monitoring. I can see some alerts throwing up. So what we can do is we can also just drill down into the geos where you can see, it shows, okay, the lifts are deployed, rather is implemented in so and so buildings. So I can just go and click on that. It will show me this particular building has 4 lifts in it, right? And if I just click on the lifts here, it's going to show me the layout, right? And it's going to if you can just move a bit. So if you can see, the lift moving. This is happening in real time. Okay. So if you see, it's showing every floor, where the lift is in every floor, the door opening, people entering the lift, and the door closing, right? And it's doing it for all the lifts. So you can imagine this is happening in real time, right? So just think of the scale of this, right? There's one other scenario. So we have done some. This again, Microsoft has invested in this. So we have implemented the sensors. This is the noise control, or rather noise levels in New York City, right? So if you look at this, we have implemented noise sensors across various locations in New York, and we're capturing real-time data, and we're doing temporal analytics on this. So you can imagine the thousands and thousands of sensors deployed in various locations, and we're doing real-time analytics. If you see, this particular location here is in red, real-time, that means real-time feedback. And if you just hover on top of that to see what it is, so I can say it's going to tell me that it's a loud music party. There's a party happening in that, right? And if you see, there's another hotspot here. If you see this, there is loud talking, right? So I can categorize in real time to basically understand where the noise is coming from, and there's various other categories such as construction and things like that. So there's a bunch of categories available. So we just look at. I can also say, hey, show me all activities, all noises that's coming from construction category, right? So it's going to show me that. So if you see, it's going to show me all of these places have a construction activity, correct? And it's happening in real time. This is in production, okay? Very similar implementation. There is something called urban air, okay? So this one, it shows particulate matter in air in Beijing. Okay, again, this is a sensor that's implemented. Microsoft has contributed to this, collaborated with the sensor providers, and implemented this here. So if you see, it's going to show various pollution levels across Beijing, right? So if you see, the green is in good status. Now there's some latency issue here. So if I just show the current state, so there are very few areas which are green. Correct? And if you I can also do some trending on this. I can say whether was it particulate matter, was it high in the night or during the day? When was it high? What are the patterns? I can do this in real time, right? So again, so we talked about big compute, right? We talked about some programming frameworks that are available. Then how do you do this kind of analytics, right? So we have something called event hubs in Azure that can ingest like 1 million messages per second, and it can also, for example, provide you can just ingest that and shove it off to a storage, or you can do temporal analytics like this. So this analytics is basically as and when the messages are coming in, we're doing snapshotting of in a small time window, and we're just pushing off to a SQL database. You want to take over?
No, how many of us have heard of Lambda architecture? Right? What is Lambda architecture?
Lambda architecture basically promotes the functional programming where you can treat function as a variable.
Okay. So Lambda architecture typically also deals with scenarios like these, where you have hot path and cold path, right? So hot path is when you are doing something like stream analytics, where you want to do live data. How does it tie back to big compute? Why big compute? Why are we talking about big compute and this year? Any guesses? That's because of the sheer size of the data. So as Anil was talking about Event Hub ingesting millions of events per second, right? Then you got to store all those millions of events or aggregate those millions of events, right? If you want to find out whether an area is red or as compared to yesterday, stuff like that, then you need to really do a lot of computation. And who will do that? Big compute for you.
So we just take a quick look at the audience framework that's pretty much used in the demos that we showed, also in the Halo game. We'll just see how it's implemented. Okay, I'll take a quick snapshot at what are the coding components and what key components and things like that. So here we'll just show you the cloud service, right? So it's a scale out situation, unlike you wouldn't see like a 64, 32 core cloud. If you see, there are about 40 instances running 1 core each, right? Supporting a tic-tac-toe game, for example, right? So if you just look at the tic-tac-toe cloud service and look at the number of instances here, you will see a bunch of web roles, right, and worker roles. So can you help us with web roles and worker roles? What do you understand in Azure?
Basically, IaaS is as platform as a service.
So web role is kind of
in a site running site IaaS.
Okay.
Okay. Web server is a web application. What is the background of this kind of thing?
That's much more closer to the right answer. Yes.
Okay.
Sorry. Yep.
So if you see, there are about 20 worker roles and 20 web roles, right? So basically what this is doing is we are hosting the web application that you saw, the tic-tac-toe. Basically it's a web application that's hosted on those 20 instances. Now I can enable auto scaling. As and when the user load increases, I can just do a scale out, right? So I can go up to, if you just look at the scale numbers here, if you just go to scale, so I just have currently 20 instances, right? I can just scale all the way up to, for example, 350 instances, right? Click on save. It's going to spin up 350 instances in the background with no downtime to my application. That's a key thing here. Now, we talked about thousands of cores, but we only seen 350. You heard that in Halo they used like thousands of cores. How do you get thousands of cores here? Any thoughts? Sorry? No. It's very simple. Customer care call. Right? So basically Microsoft wants to understand, hey, do you have the paying capacity to pay for 10,000 cores? They want to make sure that you can pay for 10,000 cores, right?
Do you have a requirement for, first of all, with 10,000 cores?
10,000 cores. So
because if you talk to our architects, they might be able to help you optimize, right?
So we are currently working on...
If you really have that requirement, as Anil is saying, talk to customer care.
Yes. We are currently working on an opportunity which requires, it's a pharmaceutical company, they require 20,000 cores and they're running 10,000 cores on premises. And in fact, they want 100,000 cores, whether Azure can provide 100,000 cores. And the answer is, hey, call customer care, customer support.
And this applies almost to most of the features in Azure. Like I have customers who come back to me and point out and say that, okay, for private IP addresses, this is the limit, right? But that's not a limit. Just in the same article where it mentions that limit, if you just look at the note, it says call customer care if you want more, right?
So if you increase the number of instances, then the cost varies or same.
Sorry, when you?
Yes, it's pay as you go, so number of instances will increase your cost.
Billing by the
That's
minute.
why the first thing you said is if you can pay. Then second of all, if you have requirement.
And it's billing by the minute though. Okay.
Yep.
So we have just 5 more minutes. I want to take a look at the HPC. By setting that up, I just have 3 more giveaways. So anybody working on similar stuff that we are doing here? Or
But we have not actually gone to the cloud. We are pretty much in this one. It
okay.
is for energy meters in home, right?
Energy meters, okay.
We are getting smart meters into the places of consumers in India.
Okay.
And that is where they will grab the data every night at 12 in the midnight.
Okay.
They want to go on the data and understand what was their energy consumption for a prepaid kind of consumer. And maybe if I have punch, I'll just transfer.
Are you involved in that project?
Yeah, I was involved in
So what was your role in that?
I'm an expert.
Okay, great. So he needs that.
Sure, definitely one for him.
Yes. Thanks. So any tough questions for us? So again, there's two more things, right? Any tough questions for us? So we have one more thing to show, which is HPC, high performance computing. And while we're doing that, we can just...
we have CPU limit, and then you can spawn new instances, right, in Azure.
Yes.
But do you have something like for RAM, like if RAM goes above 90%, which happens more on SQL servers?
Yes.
SQL server always eats all available RAM. So
Correct.
we want something like that. It is available.
See, today you can scale up to 448 GB RAM.
No,
right?
I mean, if memory goes over 90%, what you are looking for, you know, spawn new instances so that...
SQL Server doesn't work like that, right?
I have a question.
Yeah.
Basically, does Azure provide auto scaling model?
Yes, it does.
So basically, so if I need a 5 course now,
Okay.
tomorrow 50 course,
Yeah.
but day after tomorrow 10 course.
Yeah.
So according to that
Yes.
structure, can my load also calculate the price according to that?
So you can actually set auto scaling, and there are a bunch of parameters that you can configure. So one of the parameters is CPU, memory, disk in and out, okay, network in and out. So based on that, you can configure auto scaling, and you can also set minimum number of instances and maximum number of instances. You can say at any point of time, I need to have minimum of 2 instances, but my maximum cannot go beyond 100 cores.
Yeah, but then
Right?
how the pricing is calculated on 100 or?
It's by the minute. So let's say from now to next 5 minutes, use 10 cores, right? And after 5 minutes to the next 5 minutes, use like 5 cores. So you build like for 5 minutes, you'll be built like for 10 cores, and the next 5 minutes you'll be built for like whatever.
And the good
5
thing is
cores.
that you can
It's by the minute.
pre-configure, right? For an entire year, if you have a plan that, say, for example, during Diwali, you'll have more hits. So you can pre-configure and say at that time just increase. So that means your load is predictable. We even take care of people whose loads are not predictable, right? So that also is allowed.
Do you guys have anything like AWS?
I'm sorry?
So AWS launched Lambda service. Do you have something like that?
Do you have any comments on
Sorry?
Lambda?
Sorry, I didn't get that question. Sorry.
AWS.
AWS launched a service called as Lambda. Means do you have something like that?
What does Lambda do?
Yes,
Is that a code name or is an external product name?
Service means you can run a specific piece of code on the basis of events.
Mm-hmm.
So it's like this event processing. Means you don't need to allocate any CPU compute.
Event hubs.
Just the
Event hubs.
Event hubs.
Yes,
Then
event
yes.
hubs.
It's not event, but you can specifically write your own code, submit that code, and it runs on the basis of events. You don't need to provision anything.
Okay.
But where do they run?
Yeah, so if you don't need a provision, how does it run? Good question. Is it a pass?
It is a service, right?
Okay.
You submit the events, you submit your code, and it runs.
Is it like a third-party application which runs on AWS or is AWS product?
AWS
Lambda, okay.
It is in a beta.
So that's a good question. We'll probably take it offline, and I think
Yeah. So one quick thing. So we just talked about the InfiniBand and RDMA, right? So there's specific instance type in Azure which supports InfiniBand and RDMA. So if you just see this VM, it's called A8 or A9, it's an A9 instance. It's got 2 network adapters, right? It's got 2 NICs in it, and one of the NICs is Mellanox, right? It's an InfiniBand adapter that's been provisioned here in this VM. Now we'll just show the HPC.
all right.
Compute.
So much awaited HPC coming up. Well, so what I've done here is set up a cluster, and I'll show you the cluster. Cluster has got one head node. You can see here head node, and then we have got a couple of you can say child nodes or nodes that are running the processes. So let's see what it means when I say it's going to run some processes. So let's just launch CMD. And
This is the high performance computing console, HPC console in Windows Server.
let me
So this is using those InfiniBand instances.
go ahead and show you something.
So
even
they are
better.
set up on a network which is built
So
on
if you have a-
InfiniBand. Yeah.
Sure, sorry. So you have a job, say for example, say set A plus star, right? And then I say I just want to create a self-incrementing kind of a role where So basically what happens in big compute or this kind of computing is that a certain given task, and I'll run it for you, certain given task is divided into smaller tasks, right? And each task is given, and based on the number of tasks, the nodes are spun up, or based on your pre-configuration like in this case. And then the tasks will be divided across the nodes, and they will act in parallel. They can also, in certain cases, do memory transfer, for which they'll use MPI or RDMA. But in other cases, they may not do that. They may just run in parallel, right? And end of the day they'll go ahead and merge. There are APIs available in C# or .NET using which you can write code on this. Okay, so let's run this. All right.
I think we can take 2 more minutes, Saket.
Okay, sure.
Just 2 more minutes. Yeah.
How is the system different from an linear system like Exadata?
Exadata.
High performance, scalability,
Yes.
scale over that.
Yes, correct. So there are appliances that you buy and provision on premises. For example, they will require capex, right? So, for example, I think it costs around $10 million. If I don't remember, like a 4-rack, half-rack Exadata. Exadata, I think it's going to cost like $10 million, right? Now, the problem is the customers we are dealing with, they've kind of invested $10 million, and the half-rack or full rack is sitting on premises. Now, I think it comes with like 32 cores. I don't know the exact specs of that. 32 core, some specs like that. But would you need 32 cores all the time? Like 365 days a year, 24/7. Would you need 32 cores? So that's the conversation we have, right? So in this case, I can turn off my G series VM, turn it off over the weekend. I spun up a 32 cores. I need to do that right now. Otherwise, my boss is going to call me. So I'm going to turn off my G series VM as soon as I'm done with my demo. And same thing, if you're not running over the weekend, just turn it off. You just paid by the minute. You're just paying by the minute actually, right? Just use the OPEX model. CAPEX versus OPEX, exactly.
I had a question on
Yes.
the topic.
Yes.
Once you create all these applications and everything, from an operations perspective, how do you enable the monitoring part of the setup?
So we can take that offline. We can actually, there's operation insights and application insights. We can definitely look at that. Yeah.
So basically, you spoke about like these games and so many events passing through and through, right?
Yeah.
So do you have anything like do you always rely on the server to push back events, or do you have kind of peer-to-peer?
Signal.
Yeah, because
peer-to-peer,
that's
using
because the
using
command was
Signal
wrong. It should have been actually slash a
but it's not
star
polling.
to star.
We use WebSocket.
There. But this is another example of the same task that has run. So what basically we need to see here is this section, allocated nodes, right? So if you see, these are the allocated nodes on which it is running. So we go to the result, it will all show different result. So only thing is that the task is divided across multiple nodes, or the 2 nodes that we have. On the floor. Yeah.
And as we know, Azure is built on top of the commodity hardware, utility comes in basically.
Right. So, folks, actually, we're just running out of time. We have the other set of speakers here. Thank you very much for your interaction. Really love the interaction. We can actually spend some more time outside of the room. We can take any more questions you have. That works?
This is
and your feedback is very important to us. Please provide your feedback, good or bad. We'd want to know your feedback on this session. Thank you so much.
Yes. In this, yes. Like in this case, the counter was supposed to take care of the other node. You know what that guy is counting. What the yes. That is RDM.